this. I forgot to record it. Work me through the process out loud here. In other words, how are we going to add these three fractions together?
So you're going to make the 3 and 4 the common denominator.
What's the common denominator going to be?
1. No.
Here's the way to get it. Let me give you a real easy method to get it. Start with your biggest number and start increasing it by factors of 4. Now, is that number divisible by 3?
No.
Let's do it again. Is that number divisible by 3 and 2?
Yes.
That's your common denominator. That's the easiest way I know how to do it, and that works in all situations. Okay? So 12 is our common denominator, so I like to do it like this. What goes in this numerator?
6.
Okay, because what we're doing is dividing 2 into 12 and multiplying it by 1. What goes in this numerator?
4.
And this one?
3.
So the answer?
13 over 12 for 1 is 12.
Or 1 and 1/12. Yeah, either one is acceptable. Okay, cool. I don't want to go through all of these, but let's try this one.
So you change the 1/8 into the 15 over 8?
Okay, that's good. So we'll cross that out and put 15 over 8. Okay. Now,
and then change all of them to 16 on top.
Okay, so we have one. That one doesn't change. What's this become?
4.
No, now what you do is divide 4 into 16 and multiply it by 3. That's always exactly what you do, is divide your denominator into the least common one, 16, and then multiply it by the numerator to get 12, okay? And then what's this one?
Wait, so you divide 8.
8 into 16, and then multiply 2 times 15.
17. No, 2 times 15? 30.
Right. In other words, here's what I'm doing. I'm dividing 16 by 8 to get 2, and then I'm multiplying it by the numerator, 15. Okay, so 30 sixteenths. What's that?
41.
Okay, remember we're subtracting here. So there's a couple of ways you can approach this kind of a problem. You can do it from left to right, step by step. What I actually prefer doing is adding that one to that one, getting 31 sixteenths, and then subtracting 12 sixteenths, and you don't have to worry about negative numbers by doing it that way. So what's 31 minus 12? Okay, it's 19, and even if I don't know it, I can experiment with numbers in this range, and the only thing I want to make sure is that 19 added back to 12 equals 31. It's actually much easier to do that addition to get 31 than it is to do the original subtraction. So a lot of times, just think the ballpark area, and if you think, well, let's see, let's try 18. No, that doesn't work because 18 plus 12 is 30. It's not 31. So sometimes that's the best way to do subtraction. You're going to do the check anyway, right? In other words, they recommend that you do the check when you're done. You're always supposed to add 19 back to 12. Well, if you're going to do that addition, then let's just guess and don't have to do the subtraction. I mean, that's one way to look at it. I don't want you guessing, but that's the way to do accurate math, is to always check your answer.
Okay.
All right, let's go forward. What is this? This is what I really should have done from the get-go, is because you can't really master math until you mastered all of these little things. So what's that equal to? What's the first step?
Multiply by 1.
You actually have a choice of first steps, but in other words, we could add these two fractions together, right? Find a common denominator, add them together, or we could distribute the 4 to the 1/3 and the 4 to the 1/12. There might be some advantages to doing the 4 distribution first. We might not have to do some arithmetic. Let's find out. If we distribute the 4, what do we get? What's 4 times 1/3? 4 over 3. And then what's 4 times 1/12?
4 over 12.
Right? Well, 4 over 12 ends up being 1/3. So I can erase it and write 1/3. And now I've got two fractions that have the same denominator, and it's easy. So by distributing first, you kind of saved yourself the step of finding a common denominator and adding those two fractions first. So you always want to look for the easiest way to do these kind of things. Hold on. Now, you still have those same two choices. We can add these two numbers first and then multiply, or we can distribute first. In this case, what do you suppose is going to be the easiest thing to do?
Add them first.
Yeah, because they're not fractions. I don't have to go through a hard, complicated process to add fractions. So I'm just going to add 36 to 60. We get 96. Multiply it by 1/24, we get that. And now that happens to be 4 times 24. So that's equal to 4. Okay? Now, let's see how much more difficult it would have been if we'd have distributed it.
Okay.
First of all, we got that. Neither of these break into whole numbers. So we would have to add them, I guess. It's not that much more difficult, but we still get to 96 over 24, which is 4, but not quite as easily. So you always want to look for the easiest way to do these problems. Okay. What am I going to do to add these three decimals together?
Just do the 0.021 plus 0.96.
What process physically am I going to do? Am I going to leave them written like this?
No.
No, I'm going to line them up vertically. And I'm going to line them up based on where the decimal point is. In other words, when I line them up vertically, the most important thing I'm doing is lining up the decimal point. I don't want one shifted left or right of the other. Now I can just add them straight down. 461 is that. 242 plus the 1 that I carried is that. 3 and 9 is 2. Carry the 1. Bring the decimal point down. That's how you do it.
Okay.
I realize that most of this is probably review from maybe even more than a year ago for you. But nonetheless, you still need to be proficient at these skills to be successful in algebra. We'll get back to the algebra. I'm just kind of trying to get a better feel for what your math skills are at this point. And this is never going to hurt, reviewing this stuff. So how am I going to do this?
Find the common denominator.
Okay. But before I go to find a common denominator, if I'm going to work with the denominators 16 and 6, I'm going to have to count awfully high before I find a multiple of 16 that's divisible by 6. So I can simplify things a little bit first by reducing that. What is 12/16 reduced to?
3/4.
Okay. What is 3/6 reduced to?
1/2.
Let's just reduce it to fourths. Or I should say, let's now change 1/2 into some number of fourths.
2/4.
Okay. In other words, if I reduce it all the way down, then I got to go through finding a common denominator again. So if I can reduce it down and then back up to this, it's better. So now the problem becomes what?
Oh, 1/4.
1/4 squared, which is?
2/4.
No. In other words, 1/4 squared means 1/4 times 1/4. When you're multiplying fractions, it's the easiest thing. Just multiply the numerators, multiply the denominators. Much easier multiplying fractions than it is adding them or subtracting them.
Yeah.
And since division can be turned into multiplication, then division is easier. This problem right here might not look easier, but that problem is much easier than even 3/4 minus 1/2. This is an easier problem. I don't have to find a common denominator. I just flip the denominator and multiply. So I'm multiplying by 4/3. That's 8/9. Hold on. All right. How do I do this?
Do the 2 times 1 plus.
Okay, and 2 times 6, 12 with the 1 carried, 13. And then 2 times 1 is 3. Now what?
I said you have to put the smaller.
I'm having a little bit of a hard time hearing you. It's just a little choppy. What's the next step? In other words, once I get the 3 digits, how do I figure out where to put the decimal point?
How many places over the decimal?
The total number. In other words, there's 3 there and there's 2 there. So I need to go 5. I need to go, starting from there, I need to go 1, 2, 3, 4, 5. So I need 2 zeros in front. Now, once again, you need to check your answer. And what's a good way to check your answer? Always make sure you're in the ballpark. If I multiply any number by 1, it doesn't change it. So if I multiplied 0.002 by the number 1, I'm going to get 0.002. Well, I'm multiplying it by a little bit more than 1, 1.69. So that's not enough to move my decimal point. I still need to have a decimal point that starts out like that. And I know it.
Yeah.
So I always apply this ballpark check. And what you're going to find, if you're like me, is that after I repeatedly applied the ballpark check, I no longer have to use the method of counting up the decimal spots. Just make sure you're in the ballpark. By ballpark, I mean the right power of 10.
Okay.
Okay? All right. We got about 5 minutes here. Let me see if I can find some interesting problems.
Sure.
Now, I don't know how interesting, but let's make sure you know how to do this.
Can we change the 6 to 4?
What would you do?
You change the 6 and 3/4 to what decimal number?
What decimal is it?
7/5.
Uh-huh. That's one you should know without using your calculator, I think. Now I can put that underneath and subtract. Now it's easy. And you can put that 0 there. I notice most all my students end up always putting the 0 there. I tend to omit it. All right, here's an interesting one. In other words, 7/5 times the quantity 3/7 minus 2/4.
Do the 3/7.
This one, I think it's probably a toss-up as to which one is harder or easier. I would do the distribution first. Why? Because I can immediately see when I multiply this number by this number, the 7's go away and I end up with 3/5. So I keep everything small. The whole idea here is to deal with as small a numbers as possible. So let's try that tactic and see if it's easier, because finding a common denominator here, I got to go all the way to 28. And then once I have everything in 28ths, I'm going to multiply it by 7/5. 5 times 28 is going to be a giant number. So let's see if we can keep our numbers a little smaller. So when I do that, I get 3/5. You see how that happens?
Yeah.
Okay. And then when I multiply that times that, what do I get? I get minus 14/20. Well, 14/20 is 7/10. Let's write it as 7/10. Now, notice the problem is easy. I don't have to deal with any numbers bigger than 10. I'm going to turn, what am I going to turn my 3/5 into?
6/10.
6/10 minus 7/10 is minus 1/10. Whereas if I go the other way, I'm going to have some number of 28ths multiplied by this. I'm going to be dealing with giant sized numbers. All right, we got 2 minutes. Let's see if I can find a 2-minute problem. Which of the following numbers are closest to this? This might not be a 2-minute problem, but we'll see how you do on it. You can use your calculator. Do you have your calculator in hand?
Yeah.
Go ahead and grab it. Although I don't think they want you to use the calculator. That kind of defeats the purpose of this problem, I guess, wouldn't it?
Yeah.
Only way to really do the problem correctly, though, is to convert these fractions into decimals. So let's use the calculator. What's 1/3?
Okay. 0.33.
What's 4/7?
0.57.
What's 3/8?
0.37.
What's 5/9?
0.55.
And what's 1/2?
0.5.
So which is the closest?
The 0.33. No, the 0.37.
Right, 0.37.
Yeah.
And that's actually got a 5 after it anyway. So, all right, that's a good place to stop. And you're doing fine on these. We won't spend a whole lot of time doing more arithmetic stuff. We'll get into algebra next time. But I felt this might be useful to just refresh on this stuff for once. All right, I will talk to you Friday morning. Yeah, Friday at 9:30. Talk to you then, Jenna.
Yeah. Okay, thanks, bye.
Bye-bye.